Introduction to Profiling, Finding Performance Bottlenecks in Unity. Hello and welcome to episode number 8 of the Unity Performance Task Force podcasts. I'm your host, Ruben from TheGameDev.Guru, and as usual, I kick things off with a question for you. Have you ever stared at your game chugging along at 20 FPS, wondering where the hell the performance went? You tweak a shader here, disable a particle system there, maybe throw in some object pooling because someone on Reddit said it'd help, and nothing changes. That's the cost of optimizing blind. This episode is your introduction to profiling, the one skill that separates developers who ship smooth games from those who pray their performance problems magically disappear. Let's start with the why. Why do we even need profiling when it comes to performance optimization? 3 answers. First, you need to find yourself. I mean that literally. You need to know where your game is standing right now in terms of performance. Are you hitting 60 frames per second sometimes, always, most of the time, or never? You need to pinpoint where the low frame rate happens. Only then can you do something about it. Second, you need to find your bottleneck, that sneaky game sport, that missing project setting, that slow piece of code causing you trouble. Profiling helps you identify the culprit. Third, you need to understand why. Why is this specific thing the problem? What's the root cause underneath the symptom? Only when you answer these 3 questions, where, who, and why, can you craft an action plan that actually works. So what is profiling exactly? Profiling is the art of gathering intel plus reasoning about it. We don't just collect data. We transform raw data into information and knowledge. We give it meaning. That meaning helps us craft an action plan to ship a high-performing game. In other words, profiling is your starting point in your game performance journey. Only when you have numbers will you be able to make smart decisions, not the other way around. Trust me, I've wasted enough time in my life optimizing without data first. It only ends in wasted time, wasted money, and if you're super unlucky, your job. Now, what types of profiling do we have? CPU profiling, GPU profiling, memory profiling, battery profiling, lots of types. But it all comes down to getting numbers. And I'm not just talking about frame rate. You could even track how much time you personally waste as a developer. If you need to wait 2 hours for a build to finish, that's time you're losing. That affects your professional performance too. Alright, enough slides. Let's jump into Unity. When it comes to gathering data, you have 2 main options. Option 1, profile in the editor itself. You hit play, the editor runs your game, and you gather metrics right there. Option 2, profile on your target device. That's always my favorite. But here's the reality. You will never have enough time to profile only on target devices and ship games quickly. Sometimes it's fine to profile in the editor if you know the limitations. We'll dig into those limitations in future episodes. For now, let's focus on the basics of gathering performance numbers. In Unity's Game tab, there's a button called Stats. When you enable the Stats panel, you see information about your performance statistics: CPU time, render thread time, frame rate, batches, triangles, vertices, a lot of data. But remember, profiling isn't only about gathering data. Anyone can do that. It's about reasoning, transforming data into practical knowledge and practical action points. That's what you'll learn throughout this program. Now, when it comes to gathering data, we have several tools. The Stats window is one. Press Ctrl 7 on Windows and you'll open the profiler. Lots of data here too. CPU profiling at the top, rendering, memory, audio, video, physics, tons of modules. We have to be selective. That's part science, part art. The profiler window gives you a general glimpse at the important metrics of your game. Over time, these numbers will start to tell a story. Here's the thing. In a game, many hardware components are working together at once. The CPU, the GPU, memory, battery, audio chipset. Since they all work together to render your game at, let's say, 100 FPS, if one component is slower than the others or has more work, that component becomes your bottleneck. No matter what you optimize in other areas, if one specific hardware unit is the bottleneck, you need to solve that first. Quick analogy. I have to pay taxes like everyone. I work part-time for a studio. I have my companies, lots of things to manage. I can be as fast as I want dealing with my taxes. I can do the invoices, talk to my accountant, get everything done in one day. But the tax authorities, they take months to get back to me. It doesn't matter if I get my part done in half a day, I still have to wait for them to answer. They are the bottleneck. So if your bottleneck is the CPU, you need to solve the CPU first. The question is, how do you know if your bottleneck is the GPU, the CPU, or something else? That's where experience comes in. And that's what we'll build in this program. Let's say you're aiming for 60 FPS. Open a calculator. Divide 1 by 60. You get about 16 milliseconds. That's your budget per frame. If your CPU is taking longer than 16 milliseconds, that's a bottleneck. It might not be the biggest one, but it's a bottleneck. In the profiler, you can enable GPU usage recording to track how much time the GPU takes per frame. If the CPU is taking 18 milliseconds and the GPU is taking 6 milliseconds, you can safely assume your bottleneck is on the CPU. Once you know where your bottleneck is, you need to investigate who and why. You could go to the CPU usage section and look at the timeline to investigate one specific frame. You might see that the biggest cost is something called wait for target FPS. In that case, the CPU is just waiting for VSync. So you're not really bottlenecked, you're just idling because your target is 60 FPS. If you changed your target to 1000 FPS, you'd likely see a real bottleneck. See, profiling is about getting numbers and reasoning about them. It doesn't help to tell me your game runs at 20 FPS. That's only the first step. We need more data. We need context. If you say, we're running at 20 FPS and physics is taking 30 milliseconds, now we're getting somewhere. Then you ask, who is using so much physics? Is one specific object responsible? Then why is it taking so long? Maybe that object has a mesh collider that's too complex. All of this requires time, research, talking to others, and learning. We'll see a lot of these topics in detail in future episodes. Profiling isn't just about the Unity profiler, by the way. You have a lot of tools. For example, the frame debugger. At some point, you'll need to understand which draw calls you're sending to your GPU. The frame debugger lets you see how Unity renders your scenes sequentially. You can scroll through every single draw call and decide if things are happening in the right order. Another tool, the stats window's rendering section. This is the only way on normal devices to know how many draw calls, triangles, and batches you have. You can't take the stats window from your target device. It only works in the editor. So you need the rendering section in the profiler. Want to see a real bottleneck? Imagine I take my camera in Unity and position it to see the entire scene. Then I duplicate all the geometries several times. At some point, even my powerful CPU and GPU will start screaming. And there it is, 30 FPS, a real bottleneck. How do we profile? First, gather data. The stats panel gives you the numbers relevant to the current camera angle. 65 million triangles, 50 million vertices, 6,000 draw calls. This is just data. Does it help you? It helps me because I've researched what these numbers mean. 65 million vertices? Way too many. Who's causing that? Tools like the wireframe view help you find spots with tons of vertices. In this case, it's everywhere. Once you know who's drawing so many vertices, you can do something about it. It always helps to understand why this is a bottleneck. Too many triangles? We're overloading the vertex shader on the GPU. If we spend too much time on vertex shading, we won't have enough time for fragment shading. Profiling is a bit like detective work. You ask a lot of questions, you interrogate GameSpot, you write a conclusion, and most importantly, you find the guilty one and punish it. Now let's talk best practices. You didn't invest in this program just to learn content you can find on YouTube. You want the stuff that's not out there, the knowledge I've gained over a decade of performance optimization. First, check your numbers against a table of reference values. This table helps you quickly determine if something is way off the mark. I'll give you this data in a moment. Second, profile on your target device whenever possible. Switch from Play mode to Android ADB or your target platform. Performance will substantially change between the editor and your target device. But sometimes you need to lower iteration times. That's why it's useful to also profile in the editor. Third, record at least the full history of frames. In the profiler, do this first. Then save the profile by clicking the Save icon. Give it a meaningful name, something like Top View 30 FPS. Why save it? You might lose the profile. You might want to compare new performance with the previous one. And you'll be able to compare profiles side by side using other tools we'll see later. Fourth, increase the number of recorded frames if needed. By default, the profiler records 300 frames. Sometimes that's not enough. If your game freezes for a few seconds every now and then, you need more frames. That's usually a sign of garbage collection. Go to Edit, Preferences, Profiler, and increase the frame count from 300 to maybe 1000. That gives you a better view of the overall timeline and helps you identify performance spikes. Fifth, use the timeline effectively. You can zoom out or fit into view by pressing F. If you want to investigate a specific area, select it and press F again. F for focus. Sixth, always start with the big things first. Look at the timeline. What's big? Start there. If draw opaque objects is taking 8 milliseconds and prepass is taking 2 milliseconds, where should you start? Draw opaque objects. No matter how much time you spend optimizing small things, it'll never get you to your performance goal if you have bigger bottlenecks. Sometimes you can squeeze more milliseconds out of the big groups. In that case, go lower. But always start with the big blocks first. Seventh, the rendering section is ultra important. This is the only way on normal devices to know your draw calls, triangles, and batches. You can't take the stats window from your target device. Eighth, memory is important. You need to know your memory budget for your target platform. If you're developing for Oculus Quest 1, it's about 2 gigabytes. If you go above that, your game crashes. Players will be super upset. That's why the memory profiler is so useful. Ninth, audio, video, physics, physics 2D, UI, these are more niche. Only go to these profile modules if you know those are your bottlenecks or if you're explicitly trying to optimize them. If you're just starting with profiling, don't pay too much attention to them. They're too advanced. Now, I know these numbers might not tell you much yet. That's why I promised you reference values. Here's what I call the reference values table. Let's assume you're targeting 60 FPS. If you hit that number, your budget is about 60 milliseconds per frame to be on the safe side. For a generic game, project, or experience, here are the values you should target. Physics should be below 1.5 milliseconds per frame. UI should ideally sit at 0, but sometimes 0.5 milliseconds is acceptable. The rendering section of the main thread should be below 5 milliseconds. Your scripts should take less than 4 milliseconds. Animation should take less than 1.5 milliseconds. You see all of this in the profiler. For example, if animators are taking 3.8 milliseconds, that's very bad. If the rendering section is taking 28 milliseconds per frame, also bad. If physics is taking 0.5 milliseconds, that's good. Make sure you choose a representative frame, not an outlier, an average one. Second page of reference values. If you're targeting desktop or console, the CPU and GPU times you see in the stats window or the profiler have to be below your performance budget. If it's 60 FPS, that's around 16 milliseconds. You know the math. 1 divided by the frame rate. That's the number of milliseconds you have per frame. Also, if you're targeting console or desktop, aim for fewer than 2000 draw calls. Draw calls are what you see in the stats window labeled batches. We'll understand the difference between batches and set passes soon. Vertices and polygons should be below 5 million. These numbers change a lot depending on your target hardware. If you're on super high-end hardware, they'll be higher. But these are real numbers I found very useful in my career. If you're targeting mobile and aiming for 60 FPS, here's what I'm comfortable with. Number of draw calls below 200 in general. Number of vertices below 200,000. Keep this table handy and keep an open mind. So let's recap. This episode was all about giving you an introduction to profiling. Why profiling is so important. It helps you find the current state of your game performance. Frame rate, memory, loading times. It's about gathering data. How much time are you spending per category? Use the Unity profiler. Then you find out who is causing the slowdown. Maybe the terrain has too many vertices. Then you find out why. Having 50 million vertices overloads your vertex shaders. You're spending too long executing vertex shaders on so many data points. Profiling is gathering information and reasoning about it. You have many tools, more tools than you have time to learn. But the Unity profiler, the frame debugger, and the stats window are your starting points. Remember, these numbers might sound abstract now, but these will improve as you gain expertise. I'm going to make sure of that. For now, use my table of reference values. That should help you make sense of these numbers. In the next few episodes, we'll dig into the specifics of each profiling step. We'll talk about draw calls, batching, GPU optimization, and a lot more. If you found this podcast episode useful, you can access in-depth lessons in the Unity Performance Task Force program at www.performancetaskforce.com. And if Unity consulting is what you are after, book a free discovery call at https://consulting.thegamedev.guru. Till next time.